Real pleasure tonight to be able to introduce two speakers. We've got a double act tonight, so it should be twice as good as our usual events. So tonight's lecture is Central Line Improvement Programme. We've got Scott Butcher, who is CLIP Programme Engineer, and Edward Hurd, who is CLIP Senior Project Engineer. They both work for Transport for London. As ex-colleagues of mine, I know that they're going to do a great job tonight, and I'm really looking forward to hearing an update about the Central Line Improvement Programme. So thank you very much for coming to speak to us today. The floor is yours.
Do a transfer first. Hi everyone, my name is Edward Hurd and this is Scott Butcher, as Toby's just introduced. And we're going to be talking to you about Transport for London's Central Line Improvement Programme, or as we'll probably just call it throughout the entire thing, CLIP, which you'll probably hear that phrase far too many times. So we'll do a quick intro, just a little bit more detail from what Toby started off with. I joined TfL back in 2015 as a mechanical graduate engineer, and then after 2 years on the scheme, returning around the company, joined what was Scott's team, non-underground rolling stock engineering, working as a project engineer. And over the past 7 years or so, I've been working on various various projects as the project engineer. This includes lots of engineering vehicle projects, so wagons and rail-mounted cranes. And then more recently, for the past 2 or so years, I've been working on CLIP, and I'm responsible for the AC traction part of the programme. Alongside that as well, I do a lot of work with mechanical graduates currently as well, and also sponsor the IMechE's Railway Challenge.
Yeah, I'm Scott Butcher. I'm the CLIP Programme Engineer. I started on the graduate scheme as well in 2009, rolled off in 2011 into LU Rolling Stock Engineering, but had a different name at the time. Since then, I've been working on rolling stock projects on various lines for London Underground. But I've been on CLIP since the beginning, back in 2015, 2016. And so, yeah, we'll move on and start.
Yes, so just a quick overview before we get going. We're going to talk through what is CLIP and why are we doing it. Then we're going to go through a bit of a deep dive into each of the elements of the programme. Then some more kind of explanation about how we've done our design development process and prototyping. And then we'll give a brief overview on our production process that we've set up. And then we'll finish off with some parts about the future of the programme.
Okay, so Central Line Improvement Programme, CLIP, is one of the largest interventions that TfL have ever delivered on one of its existing underground fleets. The programme will improve the reliability, accessibility and safety of the Central Line fleet. Current cost is over £500 million, with 200 people working full-time across project management, engineering, planning, commercial, and a big team of fitters at Acton Depot, amongst others. So we've got millions of parts literally on the bill of materials, lots of different suppliers. Suppliers providing anything from full systems, like Alstom providing full AC traction system, right down to suppliers providing individual fixings, fastenings and electrical components. We've been working with thousands of technical requirements across the multiple projects. We are and need to deliver thousands of hours of training across installation teams and the operational and maintenance teams once we hand the trains back into service. We're just at the beginning of the production phase at the moment, currently at 15,000 hours worked, lost time injury free. Brief background on the Central Line fleet. There's 85 8-car trains on the Central Line fleet. There are 4 different car variants. There's the A car. They're the ones with the driver's cab at the front. You've then got B car and C car, which have different equipment on them. Also got a C or D car, which is similar to a C car, but just has additional de-icing equipment. Each train is made up of 4 2-car units, and coupled in combinations of A and B or B and C units. And that image gives you an idea of a normal arrangement of a train with A and B cars at each end, but the 4 cars in the middle can and do turn round and can be in any order. So a scope of CLIP can be split into 3 main areas. There's service reliability improvements. This is the replacement traction system and data transmission system, or DTS, which we'll go into detail in a minute. We're also doing car body repairs and component overhauls, addressing corrosion and the overhaul of bogies, couplers, and other components in poor condition, as well as the door system. We then got the accessibility, safety, and ambience improvements. This shows the interior of a train that's been through CLIP. It's Saloon, supposed to say Saloon CCTV at the top. We've also got a new passenger information system with visual displays, which you can see above the wheelchair space on the right-hand side. The wheelchair space is also new. We're refurbishing the grab poles, installing LED lighting, and refurbishing the seats.
So why are we doing CLIP? Built back in 1992, that's when it normally was being first put into service. It's over 30 years old and struggles with very high mileage. I think 14 million kilometers per year across the fleet, which is very high for London Underground for a fleet. And it's also overutilized. So the trains that are available are overused out of the stock, and it also suffers from quite low reliability. That's been traced back to problems with electronic equipment, having quite high failure rates, and also obsolescence issues on our electronic equipment. That in general contributes to actually the highest proportion of lost customer hours for London Underground's fleet. So the Central Line is the naughty child in the bunch. And that also contributes, as you would imagine from those topics, very high preventative and reactive maintenance costs. And 2 additional kind of contributing factors as well. We also we have quite low customer satisfaction survey scores for the Central Line, with issues with kind of hearing information on the train, lighting, and personal safety. And finally, last but not least, we're also not compliant with the rail vehicle accessibility regulations legislation, or RVAR as we'll refer to it throughout the presentation. So currently running with an exemption from the DFT at the moment until we've completed works. So to tackle that and to keep the fleet going safe and fit for purpose until it is replaced in the future, TfL have a long-term capital plan that highlights a list of interventions that we're going to carry out to meet those objectives, and that addresses 7 items covering poor asset reliability, obsolescence, corrosion damage on the body of the car, just general deterioration of the asset, a lack of CCTV linking to the low safety kind of personal safety score there, and as I mentioned before, high costs of maintaining and operating the vehicle as it is, and finally, again, last but not least, but not complying with RVAR. That links in, so we've got some interventions linked to each of those issues, and that's in our long-term capital plan. They feed back into TfL's R-purpose pillars, which are kind of generic pillars set up in TfL, which are set up so that you kind of link back to the Mayor's transport strategy. So it all feeds back to that one objective, which is providing good public transport experience. And the pillars that our work comes under fit under safety with the repairs and CCTV work, inclusivity with our RVAR compliance work, and then sustainability, not necessarily environmental, but also cost, with addressing asset performance, obsolescence, condition, and whole life cost issues. So those interventions started off as individual projects and under a portfolio, and after some time were merged and formed the program that is CLIP. That kind of was to make sure that as projects they all aligned to high-level generic strategic objectives, and other kind of efficiencies that you gain from working as a program rather than individual projects. So reducing duplication and ensuring good use of staff, say. And on the screen, we've got the 7 kind of strategic objectives that we've got for the Central Line Improvement Programme. First of all, obviously installing CCTV to improve our personal safety on the trains, making them safe to be on by repairing our floor coverings, improving accessibility by completing our RVART modification work, improving customer satisfaction, so alongside the other items above, also refurbishing elements of the train, such as the seats, electronic systems so it's more reliable, and new LED lighting to improve the ambience. Improving the reliability, as you might expect from those issues identified before, so replacing our kind of troublesome electronic equipment, such as the DC traction motors and our data transmission system with modern equivalents, and also reducing operating costs by carrying out these works, and also introducing new systems that are more energy efficient, such as AC traction and our LED lighting. And finally, trying to reduce journey times for passengers. Introducing AC traction will improve the overall performance of the train and will reduce the kind of total ride journey from one end to the other by a whole 50 seconds, which doesn't sound like much, and it probably isn't for an individual, but stacked up over our millions of customers and over a whole year, that very quickly becomes a lot of time saved for a lot of people. Scott's going to take us through the breakdown.
Okay, yeah, digging into the detail of the work that we're doing. So start with car body repairs. So this is required to prevent further deterioration of the car body structure due to corrosion and ensure it's fit to remain running for the remaining life of the fleet. So the floor has suffered from corrosion damage, significant corrosion damage. This has presented itself. There's loose floor covering within the saloons, but rain, cleaning fluid, and who knows what else has got underneath that floor covering and caused varying levels of corrosion in the aluminium floor. Corrosion in the floor can lead to issues with the integrity of the passenger floor surface for the people standing on the floor and also for the car body as a whole. So we've done lots of FEA assessments to understand the effects of this corrosion on the structural integrity of the floor and the car body as a whole, and determined an acceptable level of corrosion. So we strip the existing floor covering off, survey all the corrosion within the floor, and where it exceeds the acceptable level of corrosion, we need to do weld repairs. These aren't straightforwards. The diagram at the bottom shows the structure of the floor. It's a webbed extrusion, so we can't just cut a big section out and weld a new piece in without joining all the extrusion webs back together. So as a result, we have to cut away areas of the top skin and weld new pieces in. Any minor pitting that doesn't exceed that level doesn't affect the integrity of the floor. That's just neutralized and filled as part of the new floor covering installation. The car body repairs that we're doing, replacement of the body end panels. So the existing design is made up of 7 individual panels with butt joints. Those butt joints have degraded over time, allowing ingress of cleaning fluid and rain. Again, who knows what else. That's caused deterioration of the bond and the fixings attaching the panels to the car body ends. And so they become detached. There's a new design of body end panel that was developed many years ago. It's a 3-piece design, eliminating most of the joints and those areas of ingress, and it also, where there are joints remaining, they're improved. 50% of the fleet body ends across the fleet were replaced previously in around 2012. They were the worst ends, also the easiest ends as well, that were done previously. So as part of CLIP, well, any that weren't done at that point have since degraded even further in the past 10 years, and so they're now going to be replaced as part of CLIP. We're also installing some door corner inspection panels. The bases of the saloon door pillars are one of a number of locations on the 92 tube stock that are known to suffer from fatigue cracks. By putting these covers in, what we're doing is facilitating regular inspection of the cracks to monitor the growth and support continued operation of the fleet. These cracks are slow to grow, and at the moment it's not believed that they will limit the life of the fleet, but allowing regular inspection will ensure that we keep an eye on that problem.
So following on from the work Scott's described, which is kind of the initial works that we do in production, I'm going to take us through the new systems that we're procuring and installing on the train. And these have all been designed and manufactured by suppliers. And then the project team, have acted as the integrator to ensure that they can install properly on the train and function correctly, managing that interface. So first we've got AC traction, which is obviously my baby. The main objective we probably talked about before was about improving reliability here, reducing maintenance costs, and then also the improved performance with replacing, getting rid of the DC traction motors, which are very unreliable, and replacing the whole system with an AC traction system. And that involves removing nearly all, or majority of the underframe equipment, which includes a DC chopper case, the traction motors, our existing unreliable NiCad batteries, the static converter, which provides the auxiliary power to auxiliary systems in the saloon, and also the brake resistor, which is part of the DC chopper case, and that's all replaced with AC traction kind of equipment. So AC traction motors, a motor converter module, auxiliary power unit to replace the static converter, and just a replacement brake resistor. And that's all been designed and prototyped and manufactured as individual items by the supplier Alstom. You can see on the screen you've got one of our new motors already installed on a bogie, and then below is one of the motor converter modules with various different sections shown. I'll go through some of those sections now with another picture of the underframe. It's incredibly hard to take a photo of once installed. So this is, I'm afraid, as good as you'll get without seeing exploded images. But for each unit, we get 8 traction motors, 1 per axle, a motor converter module per car, and that includes a converter unit, a mid-frame unit, a high voltage box on the A cars to take power from either the track or the shed supply. And then on the B car, we also have an auxiliary power unit, which links to either power from the high voltage box or the battery trays that are on the B cars as well. And in each of them as well, we have a propulsion control box to manage the control of the power and the motors themselves. And that links with a lot of the existing equipment on the train. And each of them also has a brake resistor to manage and deal with the rheostatic braking from the motors. A lot of complicated interfaces with AC traction. We need to interface with the existing traction brake controller and the systems already there for managing kind of performance and movement in general. Existing wheel slide protection we have to interface with very limited interfaces with the actual system. And you've got a lot of physical interfaces as well. So we're installing this whole converter module in the same position as the existing one with the same mounting points. And this one, all the motors are going in exactly the same position on the same bogies. And so need to replicate the entire profile shape-wise and also use all the same fixing points. And also there's the interface with all the existing systems or the new systems that require the auxiliary power. Next up, we've got the data transmission system. This is another 30-year-old system, which we're replacing with modern technology. And one of the ones I mentioned at the start, it's very unreliable and causes a lot of one of the big causes for low reliability. And that's due to, I guess, general high rate of failure and obsolescence issues. The train itself, well, the work we're doing is replacing all of the DTS modules that are on the train, which there are 52 of, as well as adding new modules such as a train data recorder. We're also installing a lot of new cabling and introducing new data highways along the train so that we're up to current standards, as well as new functionality such as connectivity off the train through either Wi-Fi or 4G and 5G. And again, apart from that, we're also updating the existing bespoke network protocols, which I will not try to explain as this is the brainchild of one of my colleagues, but essentially allowing all the existing systems or the new systems as well to actually interface. And all of this is being produced and supplied by IMechE Electronics. And some of the key functions of DTS, both existing and new, it allows all the intelligent subsystems to communicate, and allows the new clip systems as well to communicate to the data to actually pass between them and provide that connection. It's going to provide the new train data recorder function. So if there are any faults that occur, it's got that data for you to analyze and diagnose issues after. It records and displays all the events and fault issues that happen to the train driver or afterwards to a maintainer. And it's also all stored using the new functionality of train, so managing the train wayside communications through Wi-Fi and 4G comms. We put that on a server for external diagnostic of issues or managing of issues, whether it be in service from a control room or afterwards by a maintainer. And again, a lot of complicated interfaces. The DTS is the hub, holds everything together. Interfaces with existing systems such as the train radio, automatic train operation and protection, the brake encoders and decoders, the primary display panel in the cab for the driver, and also the train number display on the front. We've also interfaces with some of the new systems such as AC traction, passenger information system, and the CCTV system. And we've also got interfaces with off-train systems as well. So Smart Vision being the tool which we use to look at the events and issues on that server I described, and also ACAT, which is the adhesion controllers condition assessment tool, which is used to manage low adhesion conditions throughout lethal season. Next up, we've got the passenger information system. This one's adding new visual displays in the saloon cars for customers, as well as new passenger alarm devices in the wheelchair bays. It's also adding new front-facing displays on the front of the car, as well as a new train operator interface in the cab for the operator to interact with. And it's replacing a lot of the existing equipment as well from an audio perspective, so new speakers, for example. In general, all this has been designed to comply with RVAR from, I guess, a noise level perspective, and also the accessibility with regards to the passenger emergency alarms. And again, similar to DTS, this is also being supplied, it's been designed and supplied by IMechE Electronics. And just run through some of the details on the PIS system. So we've got 6 new visual display boards in the cars, 2 in each of the kind of seating areas above, taking up all that window space. So we'll have to say farewell to giant windows as we lose that, but gain announcements, which I think much appreciated. We've got improved capability as well for any upgrades and announcements in the future. It's got the enhanced interface with the driver, that works for both communications with passengers if they were to raise an alarm. And there's a lot of existing functionality which it's replicating and having to manage, such as cab-to-cab communication. It's got some pretty critical interfaces with other systems. So it interfaces with the train radio and provides comms between the operator and a controller, whether that be in depot or on the line. There's a DTS interface with the DTS providing a lot of the key information with regards to where it is, what time it is, and what it needs to say. And then finally, also an interface with the new CCTV interface. And in that one is an interface where the CCTV will capture the audio logs when an emergency alarm is pulled. Whereas normally it's not recording anything, but it will take that recording of the communication between a customer and the operator if and when the alarm is pulled, and that logs up, sits with the visual recording, which takes us to the next one, which is the new Saloon CCTV system, which I think I've said right that time. This is going back to our main objective, or one of the main objectives about making people feel more safe, personal safety improvements on the train and improving customer satisfaction. Having that system on board, it also helps with fault finding. If we've got issues with doors or other systems on the train and we're not sure how something happened, we can look back at the evidence that's recorded. We've got 2 6-megapixel fisheye cameras mounted at either end of the saloon in the roof, which you can see up on the left. And that all the data from those cameras is stored in a digital video recorder, which is hidden away in one of the seat bays on the left there, which stores data for up to 30 days, so we can go back and see anything post-incident, which is especially useful with regards to kind of anything involving the BTP, if they need to look back at something that hasn't been raised immediately. Just a few extra bits of info on the CCTV system. There's a bespoke media player which comes with the system called Mobile Manager, which de-warps, I don't know if that's a real word, but de-warps the fisheye lens image into 4 flat images of each of the sections, and allows you to look back at the recordings and any kind of associated data or audio from the PIS system and any comms that were recorded part of an emergency. And there are a lot of interfaces with CCTV. So you've got the information from DTS being provided about time, location, as well as PIS information such as the talkback information or the data recorded and which PAE was actually pulled. So we'll move on. Scott's going to talk to you about LED.
Oh, yeah. So image here is the existing lighting on the system, which is fluorescent tubes. There's 2 tubes behind a central bank, which is a hinged glass diffuser, and then 2 banks of tubes above the advert panels on each side. The center ones in particular behind that glass diffuser get dusty and dirty, affecting the emission of the light. Fluorescent tubes we can't get hold of anymore. So we're replacing that with LED lighting. These are LED panels which exceed the minimum lighting levels. They replicate the form and aesthetics of the existing lighting, with the central bank and 2 side advert panel banks. There are 6 different variants of the center luminaire and 3 different variants of the side advert luminaire, which is mainly to do with the length and has differing lengths down the length of the train. They're now line replaceable units sealed to IP65, so a wipe of the exterior surface is all that's needed to keep them clean and functioning. Failure of any individual chains of LEDs within the luminaire is compensated for by an increase in the intensity of the other chains, which gives us some redundancy and maintains the ambience. Okay, and then moving on to the saloon modifications. This is really all the bracketry and cable routing to integrate all of the systems we've just covered into the saloon. So LED lighting at the top, the CCTV bracketry in the ceiling, and the visual displays in the windows, all the bracketry and paneling to surround that. Also introducing the wheelchair spaces and contrasting floor covering, as well as a new door threshold strip, as well as the seat overhaul. So the wheelchair spaces in particular, these are in the B car of the AB unit. So in 2 cars on every train. It will be the nominated wheelchair car will be the second car from the back. This is to align with platform furniture used to get wheelchairs on and off of the trains. There's a new PEA alarm, passenger emergency alarm, which is part of the passenger information system, which is positioned to optimize the optimized position for a reference wheelchair user. You can also see the new passenger information display above that area. This seat bay in particular was chosen to convert into the wheelchair space because, unlike most of the other seats across the the full train, there wasn't much equipment under the seat. So we're able to build this perch seat structure that you can see on the right hand side around all of the door equipment. And there's just some pneumatic manifolds that we had to relocate into that center backboard cupboard. We've retained the ceiling handrail in that area, but we've had to move it up out of the way as we're introducing perch seats at the side of the train. If you're as tall as me, you'll bang your head on the existing grab poles. So that's been moved back up towards the ceiling to reduce the risk of any head knocks. We've also introduced a new sill plate design. You can see in the bottom left here, that's the new sill plate. If really good eyes, you can see the existing sill plates on the train next door. What we've done here is improve the interface between the floor covering and the sill plate. As the existing interface is a route where a lot of the corrosion is initiated from within the floor. We've also introduced a threshold strip, a yellow threshold strip, to offer contrast between at the doorway edge and to indicate the step to the platform, and that's removable should it wear down in time. Also replaced the floor covering. This is now the existing floor covering is one color throughout the car. We've now got contrast between the doorway areas and the seats. There's a new rubber floor, a new adhesive system. A lot of work has gone into selecting these materials to try and eliminate the common issue we've got across London Underground fleets with the floors bubbling up, the bond breaking down, and then resulting corrosion underneath. Grab poles are being refurbished, repainted in a slightly different shade of red. They're remaining red, but slightly different shade to improve the contrast between the grab poles and all of the surrounding areas. And we're also refurbishing the seats and introducing the new maquette. This is a new maquette that was selected out of a number of designs that were put forward specifically for clip. It was then named Tuppenny, which is the cost, the initial cost, original cost for riding on the central line when it was opened, and that was voted for by TfL staff. There's also improved contrast between priority seats. At the same time as clip, we're also doing door overhaul and program lift activities, or doppel. This is routine overhaul of equipment required to maintain safe and reliable operation. The overhaul dates of some of the critical components are now driven by condition assessments, and they show that they won't last. They won't continue to operate safely and reliably until the trains go through clip. So as a result, there's a separate doppel line running in parallel to clip. Trains will come over to Acton, go through the doppel overhaul over a 10-day period. Trains will go back out into service before coming around later to go through the clip modification cycle. So yeah, door system overhaul is overhaul, condition assessment, and replacement of number of components that are subject to wear. And similarly, program lift, there's a number of bogie overhaul components, and also other components outside of the bogie, coupling systems, and stuff within the cab, electrical and pneumatic systems. Okay, so moving on to the design development process that we've taken. This gives a very high level program of where we started and where we're going. So it's around 2015, 2016, 2017, where TRSs were developed and competitive tenders were issued for multiple design and supply contracts. Those contracts were awarded, and designs were developed about 2017 to 2019. This was multiple different contracts, multiple designs running in parallel, lots of very complex design interdependencies during this period. Once all the designs were developed, we moved on to prototyping. As Ed mentioned, the DTS is the main interface between all of the new systems. That enabled us to do one prototype train that was AC traction DTS only. In parallel to that, another prototype train with DTS and all the other Saloon modifications. That then came together into the third all-clip prototype train where everything was installed for the first time. And that became the first train to enter service November last year.
So a key part of the design development is our design review process, which is stipulated in each of our technical requirement specifications for the projects. That covers the kind of usual stages that you'd see in design development: concept design, detail design, testing phase, and then in our case, a build phase, which we're carrying out. Each of those has an assigned kind of design review stop point where the suppliers are defined lists of documents the suppliers are given have to be submitted for TfL to review and provide comment on, which is all collated in a very large outstanding issues list spreadsheet. And that's culminates in a normally quite intense design review period, normally a week or so, where all the issues are gone through together in one room or one location. So I've got colleagues here who probably have fond memories of going to strange places in the UK or abroad to sit in a room for many hours talking about spelling mistakes or actual design issues, depending on the reviewer. Those all line up with assurance deliverables that we have as part of TfL, defined as part of our assurance standard, which are parts or documents that teams have to produce using all the information provided by the supplier. And those allow us to proceed to each of the next steps and also carry out a lot of the key kind of design development work. So moving from concept design to the detailed design requires a concept submission and agreement in principle with our asset owners. Moving from detailed design to testing needs a compliance submission and letters of no objection from our asset owners as well in London Underground. And then throughout the testing phase, you have different stages of consent to test to allow us to test in various stages around the network. And each of those also all agreed with different asset owners to make sure they're happy for us to run the vehicle there or to carry out the tests we want to do. And that all finishes off with our production readiness review for everyone, where we review the final design and check all the production documentation is there for us to start in anger to produce tens to thousands of components, depending on what we're making or the suppliers are making for us or we're procuring. And that's captured in a consent to operate, which allows us, has allowed our clip train 3 to go into passenger service last November. Just give a bit of an overview then on our prototype train 1, which had AC traction and DTS on it. This is all built up in Derby with the AC traction equipment installed by Alstom and a third party carrying out the works for DTS on that train. We then carried out initial unit level testing up at the Railway Innovation and Development Centre, Melton Trest Track, or Riddick as most people just call it. Started with a unit testing and then following that through our design review process, moving on to train level testing at Riddick before coming down to Ruislip to start depot and then mainline testing on the central line. So hundreds of tests being carried out over that train, all of it in the aim of providing evidence to demonstrate that the supplier and the system is compliant with all the requirements in the TRS. And for anyone keen-eyed, there is snuck between on the right there a central line train hidden amongst Piccadilly line trains over in Northfields, which was part of our brake testing that we do that way.
In parallel to prototyping on train 1, we did prototyping on train 2. This was the first car to have the saloon works and the car body repairs undertaken. This was done at Ruislip Depot by the in-house train modification unit. This is where it got really interesting for anyone working on this, as shortly before we started prototyping on train 2, the design supplier who was providing the designs for all of the interior installations, the bracketry and the cable routing for all of the systems within the saloon, their contract was terminated, and TfL Engineering then took on the design. That was developed really throughout the installation on prototype train 2. We also had, which was also coincided with COVID lockdowns. There were lots of fun and games with 2 people at a time on the train, and really material supply challenges that really slowed us down. As a result of that, we focused on getting the train into the state it needed to go out and test on the central line. The image on the right shows you what the train looked like when it was out running and testing. So all of the new systems were in and functioning, but the interior was entirely stripped out. While train 1 and 2 were out on the central line going through all their testing, train 3 was initiated. This is the first train to have everything within the clip scope, everything done to it. And it was also the first train to be installed at Acton in the new installation facility. This was the first train to enter passenger service, which did so in November last year. It was initially running short paths on the open sections before building up through running through the tunnel, and then multiple return journeys across the full line. 5,000 kilometers of running was achieved in April this year without any service affecting failures. We have, however, had to make a number of significant software updates to resolve issues that have emerged throughout operational service. We're on track now to hit operational level 7, so seventh stage, which is the handover back to fleet December this year. Okay, so we'll move on to production quickly. So the modification work across the fleet is being done in Acton by London Underground, the in-house train modification unit. There's a new shed, AC14, that's been built specifically for clip. They'll obviously be used afterwards. That has capacity for 4 trains on a bogie road. Also utilising an existing shed, AC15 at Acton, which has capacity for another train. And this allows segregation between the dirty strip out works, create dust and swarf. That's going to be done in AC14, so the AC15 is kept clean for the installation of the new equipment and all the electrical connections. Currently have 200 electrical and mechanical fitters working on the project at Acton. There are currently 5 trains in work. We're building up to a 50-day production cycle at full beat rate. This will be staggered across 5 trains in work at any time, which means a clip train will be reintroduced back into service every 10 days. This is a quick overview of the 50-day production cycle. So the train is transferred to Acton from Ruislip Depot and works its way through the production cycle before being transferred back to Ruislip, where there's recommissioning and re-entry into service. Break that down a bit more.
Yes, we'll go through each of those stages out of the 6 that we have there on the overview. Stage 1 is carrying out a pre-modification inspection of the train before it leaves Ruislip Depot to make sure, see what state it's in, agree any work that should or shouldn't be done as part of clip, and also make sure we're not doing extra work or it's all within scope, and we're prepared for what needs to be done on the train. It then gets transferred from Ruislip to Acton at night along the Piccadilly line. Then entering stage 2, where it arrives on our side roads, gets split into 8 cars and put into our AC15, which is the dirty shed where we strip out all the equipment and carry out our corrosion damage assessment and repairs. As you can see here on the left, you've got the stripped out car, basically nothing in it, and covers over the seat bays that we can't touch the equipment in there. And then you've got on the right some weld repair work on the right. Then on to stage 3, we're still in AC15 at this point, and we carry out our door sill installation, which you can see on the left. We carry out the wheelchair space modification and installation to prep that, which is on the right, and a lot of Saloon bracketry, for example, all of the passenger information display bracketry that we needed to install those above each of the seat areas. We also installed a lot of the overhaul components that we get back from the door overhaul process and any other interior panel modification work, such as the door corner inspection covers. Then moving on into stage 4, we take the train, put the cars back into units and move them over into AC14, where we start work on our lift road, where we remove the bogies and the existing DC chopper cases and other equipment. So the train becomes very bare very quickly. We then work on the AC traction equipment installation and all the connection cabling that's required between the new systems and different components that AC traction installs. There's also a lot of other existing. I'll pause for a second. Okay, right. Where was I? We'll go back to the start. We've lifted the car or the unit, and we've removed the bogies and sent them off, and we've moved the DC chopper case equipment to be kind of a lot of scavenger work, and a lot of reclaimed equipment gets taken from that to use back on the fleet. So whilst FIP's ongoing, the fleet gets more and more spares, which it can use, which is very useful for them. Then we install all the new pneumatic system, or the updated modifications to the pneumatic system, which is basically moving pneumatics so we can fit the new equipment, and also the electrical cable kind of integration is carried out for us then to install all the new equipment underneath and then connect it up. There's also some underframe program lift overhaul work carried out. And in parallel to that, on our bogie road, we've got the bogie overhaul ongoing, as well as swapping out our DC traction motors with the new AC traction motors. And that finishes off with the bogie refit, and we lower it back down and move on to a non-lift road.
Yeah, so this is where we do the saloon installation. By this point, all the bracketry is in. So this is module installation, electrical cable running and connections. Across all the systems, there's new modules in most seat bays. There's the visual displays in each window, stuff in the ceiling, and the main cable run is down the ceiling as well. So there's pretty much joining up every seat bay, window, and ceiling via the door pillars. A lot of electrical installation at this point. Following all of that, the interior paneling, the seats and everything goes back in, and then the new floor covering is laid. After that, installation is complete, and we move on to testing. It starts off with installation testing to ensure that the installation has been done correctly. We're moving on to functional testing to prove that the new systems are functioning as they should. The train's then handed over to the product introduction team, who then transfer the train back to the depot. That transfer will also serve as a proving run. We'll then do any outstanding routine maintenance before the train is returned back into service, all within 50 days. So now we're nearing the end of the design phase for Clip. We've got the prototype done, and we're moving into production. We've got to get down to the 50-day production beat rate. So big focus on this. There are multiple work streams ongoing, all associated with introducing a brand new production facility, bringing new production teams on, developing hundreds of work instructions, working with the thousands of new materials, and implementing hundreds of quality control interventions. So the ramp up looks something like that at the bottom. Over the next year, we're aiming to hit a 60-day beat rate, which will have a train into service every 3 weeks, and then 26-27 onto the 50-day beat rate with a train every 2 weeks. And that'll take us through to 2029 when all trains will be completed.
And all of this will be enabled by our product introduction team, which is setting up at the moment, which works in parallel with the production site. They're responsible for the rail transfers, taking the trains back and forth, managing the interface with our fleet colleagues, tracking and managing any reliability issues, making sure that we get the reliability requirements that we've set out in our TRS is delivered to us, and if not, managing that with our suppliers. A lot of training as well is delivered by our team, and also essentially all of the enabling works for the train to be given back and used by operational maintenance staff as a normal train. So critical to delivery at the end of the stage is this team working smoothly and operating well with our fleet and operational colleagues, giving it back to them, all in the aim of giving us all those benefits that we described at the start: the improved reliability, lowered maintenance and operational costs, the increased energy efficiency, the improved ambience and customer experience in general, and improved safety. All of it then tied up with the PI team delivering it, handing it back over to fleet to be used. So one train at the moment's out, another one by the end of the year, a few more next year. And for anyone in London, hopefully you'll start to see these trains running around. Basically, just look out for those seats and you'll know it's one of ours. That's it for the slide deck. Now, time for a bit of Q&A. I don't know how much time we've got. We've run over maybe a little bit.
Yep.
Right, thanks, guys. I thought that was an absolutely fantastic, really fascinating presentation. Thank you for giving us so much information and really going into some fascinating detail. Yeah, so Ed and Scott are now available to answer some questions. So we'll open up to the floor for the first question. I'm going to try and do my mic thing, and I'm going to get you to answer questions into the mic.
Yeah, thanks for that, guys. I'm going to sneak in two questions. One, the central line had issues with its motor staying on, so it had to replace corrugated track to sort of different standards than the rest of the network. Will that issue be resolved through CLIP? Do you know? And secondly, I'm just interested in the asset management thought, because 500 million is a lot of money to keep an existing asset going. And is there, like, how much does a new fleet cost, basically? Because Central Line, like you said, is sort of a problem child. So I don't know, was that even a thought to have a new fleet rather than spending so much money on keeping the existing asset going?
I don't know about corrugation.
No, I don't know the answer to the first one.
I'm not aware that we suffer from corrugation too badly at the moment. If we do, we've not been told to fix it with this program. Not an intervention required, I guess, is the point there. And with regards to the costs, it's supposed to last. I mean, the traction system is designed to last 30 years, so it's going to keep going for a long time. Whereas I think the cost of a new fleet in the billions, £3-4 billion for a new Piccadilly line fleet, say, it's a lot less to keep the train going for a lot longer. So it's well worth doing to keep it going that long.
Yeah, I think because the program has been going on for such a long time, the business case has been revisited numerous times, and it only seems to be getting stronger with the condition of the existing fleet. So Central Line is desperate for CLIP.
Cheers. Chris Welford, CPC. Guys, really good presentation. Thanks very much. I noticed you said the WSP system's remaining, so not being changed. Was there any integration testing and optimization and change of the WSP system configuration needed to achieve that? So obviously the WSP system, I have a bit of knowledge of this from history lessons down the pub from my old boss, was quite optimized to the old traction system. So the new characteristics, particularly with that 50-second improved runtime, must mean there's some difference.
I actually spent a lot of my summer, about 4 weeks of it down in Acton doing brake testing, and a couple of those days were WSP integration testing. The new system has been designed to have the same interface with the existing WSP system. The WSP system monitors and provides that protection when required, and the existing DC traction system basically just doesn't do anything and lets that control and manage the issue. So the objective for the new system was simply to replicate that and to allow the existing system to maintain and do its thing. And that was actually quite a big challenge because the new system, software-wise, the way it controls slip, slide, and that functionality is built into both tractioning and braking. And you can simply turn off those functions, I think. But then there's a case for what if WSP doesn't work? Surely you should have a bit of both. So there's actually a very complicated, or quite complicated, functionality in the system where the new traction system attempts to mimic what the WSP system is monitoring, replicate that, log the same things, do nothing until it knows that the WSP system should have kicked in. And when it's not, then it starts to engage its own control of this slide. But that's all been tested and confirmed as matching the performance, which, yeah, a successful August for me at least.
It's good to hear. If you've got a question online, if you can put your hand up, we'll be able to come to you if we want. But yeah, okay, question if you want to try and speak in.
Shout out. All right, okay, all right. First question is, you didn't mention anything about the ventilation upgrade. Is there, maybe I missed it, but are you doing that? And then second, is there any infrastructure upgrade that supports CLIP as well? Because you mentioned you're going from DC to AC. So like power consumption, any power upgrade associated with CLIP?
Ventilation wise, there's nothing, is there?
No, nothing scope to change anything ventilation wise. There are options for infrastructure changes, I think, but they will all follow. They'll follow the train modification.
There has been infrastructure testing to confirm that the new AC traction system does function correctly on our infrastructure from like a power perspective. And there is options in the future to increase our regen voltage once infrastructure upgrades are completed. But that isn't compatible with the DC system. So only once it's all completed can we start to engage that. But I think infrastructure works will probably go on in parallel when that's ready.
I don't think it's an easy problem to solve.
Yeah, there is force vent convection cooling in there, but there's no aircon and there's no room for aircon. So it's how do you improve that? I guess more efficient trains, which we are introducing. But overall, I think there is a notional I think increase or decrease. Sorry, when you've got AC traction completely installed, there is a I think a 1 degree decrease in temperature across the fleet or the infrastructure, which I'm going to appreciate, I think, but probably don't want to notice.
Also cooling the tube. This is
keeping it not getting hotter, I think, is whatever the project's called.
Great. Okay, we've got another question here.
Like it's very insightful and very detailed filling, which is amazing. But my question is, when you have these wheelchair bays installed, would you also be working on increasing platform height so that people in wheelchairs can get into these accessible places easier on the train?
So the method for accessing the trains from the platforms is manual boarding ramps. Central line is the way the doors are designed on the central line. They're hung on the outside and extend down below the platform. It makes it very difficult to get the gap between the platform and the train. In fact, you can't get a compliant gap. So adding humps onto the platforms will still leave you with a big gap between the platform and the train. So as a result of that, is manual boarding ramps is the method that's going to be utilised.
Scott, any more questions from in the room? No questions online. Okay, well, oh yeah, or what? Right at the death. One question.
Hello, Scott. Hello, Ed. Thank you for the presentation. I was wondering how all these modifications affected the train weight, and also if you're allowed to say what some of those emerging issues were that you talked about, which were being kind of fixed through the software? Thank you.
Overall, an insignificant increase in weight. That's mainly due to the traction system being lighter than the existing system. So it's a negligible increase. Yeah, some of the issues with the software, software issues around the passenger information system and DTS, where in operational scenarios where you have multiple things occurring at the same time, then in particular the operator, their handset, they use one handset telephone, looks just like an old telephone, and that's used for all manner of communications. In particular scenarios, you want a hierarchy of what level of communication overrides other levels of communication. So if you're in the middle of a communication between the front cab and the rear cab, for example, and an emergency announcement comes through from the line controller, then you're going to want to hear that emergency announcement. So in particular scenarios of particular communication scenarios, there were some issues with the correct hierarchy following through. So this was mitigated by the use of additional handsets and technical riders on the runs that were made out on the line.
It's great. Thank you very much, everyone, for your questions and your engagement with the presentation. I think that just leaves me to wrap up and say, I mean, thank you for sharing all that information and being really insightful. It does look like we're almost getting a completely new train with the amount of work that's going on, seeing those photos, seeing how much work is going into it. I wasn't sure what you were keeping as part of clip. It is going to be a real change for London Underground's customers, and I'm sure they're really going to notice the improvements as these new refurbished trains come into service. It's clearly a lot of very good engineering and detailed technical work that's gone into it, and it's really fantastic to see. So I really wish you the best of luck with the project, and I'm looking forward to being able to ride on one of the new clip trains at some point. Without further ado, I think we should thank Scott and Ed once more in the usual manner. And thank you everyone for attending online and in person. It's great to have such great engagement on these events. Our next talk will be on the 20th of November, and that's going to be on intelligent infrastructure, presented by Martin Mason from Network Rail. This is our last talk at this RSSB office, and we're going to have our next talk at TfL's office at Palestra. So please look out for that one. Register if you'd like to attend, and I hope to see you there. Thank you very much.